Bueno, esta charla puedo darla en castellano o en inglés. No sé hablar mucho portugués, creo que conozco picado, crianza, y eso es todo. Muchas muy importante. ¿Qué prefieren? ¿Inglés o español? Manos. ¿Inglés? Ok. ¿Español? Bueno, lo voy a hacer en inglés porque vamos a respetar a las minorías y somos inclusivos. Okay, my name is Nahuel. I come from Patagonia, and I'm going to do an overview of a project I'm working on. First of all, some disclaimers. You already know I'm not a good speaker in English, but definitely worse in Portuguese. And some material that I show cannot be distributed, so if you have some specific doubt, you can approach me. Well, I'm a member of a research group at Palestrante University focused on networks, on microcontrollers, and everything that is related with those two things. I am a chief of practical assignments. I'm a Python advocate. I gave many courses at my local university. I frequently talk in the Patagonian Python meetup. And I've been chair for 2 years for SciPy, thanks to Juan here in the audience.
Sorry.
Yeah, you definitely are. And well, I worked for 3 years in electric transport station industry. I did a little organization since I want to show many things. The first thing would be monitoring processes with Python, and I'm going to cover construct, listed, and Django. Maybe some of those packages are familiar to you. Then Python in tooling. There is a very interesting project called PlatformIO. Then Python in the microcontroller, and then I'm gonna speak about some conclusions we had in our research group. Well, the first part of this talk is gonna be about power substation monitoring with Python. These are the general requirements that we had. We need a noise resilient protocol. Well, you know, in power substations there is this thing called electricity. Electricity generates lots of noise, and electronic devices sometimes don't work as we expect when there is a lot of these fields around them. So we need to make our networks resilient to this kind of noise. We wanted to interact with very old hardware that was not supposed to integrate in a system, or at least not in a way that we wanted. Well, we wanted some web, shiny, nice at that time, web UI, and that's why we used Django. We wanted some reports in specific formats, and as always, as cheap as possible. Well, these drawings are not mine, but I stole them. Maybe I can make it a little bit bigger. Okay, this is the general schema. There is these devices, the electronic intelligent devices, are connected to the machines directly, and they have a network RS485, and they take states and events from the network and store them in this big microcontroller that we solve from our SCADA process and store that information in a DB. This guy has to store things for safety. Something happens with this network, it has to have some memory, so it has to higher amount of memory than these more small devices. And I think I have some pictures. So, well, this is the same schema, but now with these, with microcontroller, with other vocabulary. This one's very important. These are the power meters that we worked with. They are called Alpha 2, I believe. And there was the board that we inserted there and made some reverse engineering, maybe violating some contracts, but we needed to be cheap. And the concentrator was a development board by Microchip that make great products for electronics, but they don't feel like, I don't know, if you are used to work with open source software and you start to work with Microchip PIC, they have nice IDEs, but the command line tools are hard to integrate. Back in that time, it was the solution. I'm going to talk about it a little later. We wrote our own protocol because we needed some time synchronization. Whenever something happens, you must know exactly when it happened, and you have to have some notion of lower time in the system. So basically, we wrote a very basic protocol that has some fields like start of frame sequence, the length of the package, the source, the destinations, and comments, and some checksums. And inside these three dots, we have variables that indicate the state of the microcontroller, the digital inputs, the analog inputs, and some events. Well, we can see this stuff working right now if my SSH connection didn't go away. Let me zoom this in. Yeah, well, there are some exceptions. I don't want to explain this, but basically, we can see here like a state of a state machine. These characters that appear after that is the response from a microcontroller that is in that IP inside the network. And when every package comes, we have. Oh, now I need to zoom out. Maybe this. I don't have control key. Actually, I have one, but I don't know if that's has the same meaning as the PC. Okay, how did we make those numbers become Python strings, dictionaries, and all that data types that we love? Basically, we use Construct. Construct is a great library for parsing binary particles. It's far better than Python owns Construct. Here's a real example taken from the GitHub repo. From the schema that I showed a few slides before, I have this definition of start of field, length, destination, source, sequence, command. We can define this if statement. So if something is present in the package, we can include different structures, and we can have arrays of stuff, and all those definitions become a Python dictionary, and then you can use them to store it somewhere. Well, initially we worked with SQL Alchemy. It was a very nice tool and fast, but with time constraints, we decided to switch to Django, since it has a very nice admin and has some REST plugins that you can use. Oh, this is very small, but basically we had like, no, it's impossible to read, sorry. Okay, we have like the system variables, the DIs and the IEs. Those inherit from a generic MB model, measured value it means, and basically we wanted to store every frame that came from the microcontrollers in the GB and overwrite the previous values, and if it was an event, store it somewhere else. So we did it very easily with Python. I have a for loop that iterates through the DIs. Payload.dis is the stuff that comes from construct. And we have, well, in this case, we have self. It's part of a method, of a class. But basically that DI takes from the ORM the instances of the DIs linked to that specific IED. Well, maybe I need to be more specific here. I think I have the whole code link here. But basically, Python was a very nice tool, and we could make this stuff very quickly. Okay, it's not loading. I'll try to show you later. Okay, so we have all the stuff in the DB. We have a connection with microcontrollers. Now we have to show something to the user. Specifically, HMI, the human-machine interface, is a set of graphics that represent the state of the process. And at that time, SVG was supported in most browsers. You have in the IPython notebook an SVG definition. That definition is showing that rectangle, and if I change something, for example, replace a 0 for an F, I can change the color, and basically that was the main tool, changing properties in an SVG. We did it with the V3, but we didn't exploit all its features. There was some guy in charge of drawing things, and he took Inkscape, a very popular open source drawing tool that works in every operating system, and he drew the schema of the power station and put IDs on every element that was supposed to change when some data came. Well, basically, to make that SVG schema interactive, we defined some SVG elements that is part of a screen. The screen is a file. That file may have a parent, and it may have links to other screens, and basically it's a tree structure. And we define another application in Django that store those stuff. I'm not going to zoom in because it takes a lot of time, and I want to show you some real demos. Okay. In some cases, for example, here we have a power line that works at 13,000 volts, and that value is measured somewhere in the field, and some of these values depend on that value. They are calculated. Not all the values in the screen are taken directly from the field, so we have to make some calculations. And at that point, we couldn't find a common language between the software guys and the electric engineers. So they seem to be very fond of Excel. And basically, we created a DSL using Excel as an Excel-ish language. And in this case, it is in Spanish, it's an if statement. And in this case, it's taking a DI, digital input value. It has this ID, and it's taking the value of that row in the DB. And well, basically, it's testing if statements. It's not great for us, but it works, and they can change it. And that's why you saw those exceptions there, because they are changing stuff with their DSL, and we don't have to program anything. They understand that they can take an object in the SVG file and create a formula for that element. They know the fields that are being reported by the microcontrollers. So it's that way the user can interact with the system without assistance. Another requirement was to plot stuff. This is a very old D3 plugin that allowed to make some nice plots of power consumption. I don't want to go in deep detail because we have nicer things like Bokeh or Matplotlib. Yeah, I would. When I started this morning to talk about Bokeh, I thought, okay, maybe we should rewrite that thing. And basically, that was the experience with Python. We made all the host things, or the things that run the servers in Python, and we have a very nice experience. But the group of guys that worked on that project, including me, started to see different other scenarios where our approach of asking the microcontroller for stuff was not ideal. We needed something more flexible. And we started to hear about these IoT things. For some people, it's a buzzword, but basically involves some concepts like more variety of devices, and well, in our case, we choose Arduino because it was easy to pick. There are other tool chains to build stuff for microcontrollers, and particularly the Arduino IDE is not that great. We are used to Vim, Emacs, Sublime, Eclipse, many other IDEs, and we needed something more flexible. And we found this project called PlatformIO that is written in Python, and basically, well, this is a description taken from their page. It has a colorful command line output, something that we love. It has an IDE with IDE integration with, well, the Arduino itself, Atom, CLion, Eclipse, Emacs, Energia, Qt Creator, Sublime, Vim, and Visual Studio. Well, cloud compiling and continuous integration. It has a serial port monitor, something that we use in Arduino all the time. And some preview tool chains. I want to show you a quick demo now. Well, and they have this, yeah, this is basically the supported platform at Mel, expressive, Freescale. Well, I'm going to show you now with, I don't know if it's, no, it's too small, but basically you are seeing now in Atom auto-completion, something that you don't have in Arduino IDE. And basically it's also suggesting types for things, and it's running, well, in this case the code was very, very small. Okay, well, I'm going to show you now an example with this board. This board is a Node MCU. It's a very popular board based on a chip built for light bulbs. you to turn on and off your lights with your cell phone. And in this case, the Wi-Fi chip is connected to a microcontroller that you can program with the Arduino APIs. Okay, I was trying to show my camera. Okay, I have my camera here. I don't know if I have a red light LED there. I'm gonna try to, okay. I have some code here already written that I will explain later. I have this PlatformIO menu and, well, it's too small, but believe me, there is an upload entry here. Basically, it's trying to compile everything. Not everything changed. Okay. This thing doesn't seem to. Okay, you see that blue light there? It is being programmed. When it finishes, it stops blinking. Well, it takes some time. Okay, now it boots, and we have a connection to my portable Wi-Fi router. And to understand what's happening, we had to go into something new called MQTT. How many of you know about MQTT? Okay, it's very popular. Basically, MQTT is a message-oriented middleware from Oasis. Actually, it's from IBM. Oasis made it as standard. It's designed for constrained devices and basically allow you to send messages with a topic and a payload. It has open source and commercial implementations, and Facebook used it for its messaging application for cell phones. And well, I stole this slide from Microsoft. You have different kind of messages. You have quality of service 0, where your message is not worthy to be delivered. You have at least once and exactly once. This is the most expensive, but when you have money involved in your process, you are going to use this one. Okay, well. Okay, I have an example here. I installed an MQTT broker in my computer. It's called Mosquito. It's from the Eclipse Foundation. And basically it has a command line application that I'm going to use. It's called Mosquito Pub, and I'm going to publish a message with this topic. ESP/LED. And the message will be 1 or 0. Okay. I have the light on, so I'm going to run the second line in order to turn it off. Okay, I have my camera is on desktop. I'm going to run this command, and I'm going to focus the camera application. And I'm going to run this command here, and the light. Come on, I have to click on it in order to have the camera running. So basically, I'm running a sketch that has I don't know if it's readable, but basically has Arduino APIs. Wi-Fi client is an Arduino API. PubSub client is a class that I installed with PlatformIO. I pulled it from GitHub, and well, I didn't use this menu. It has a lot of features, but I like the CLI. I don't want to go into detail right now, but if you haven't used Arduino or want to use Arduino, I highly encourage you to try PlatformIO. The guys that make it are always in either, and if you have some question about, I don't know how to use this particular device, they're gonna respond any questions you have. And well, the last part of my talk is gonna be about Python in the microcontroller. So the middle part was about IoT, and I have some plans to integrate stuff with MQTT. And I'm going to run MicroPython in this board. It's called, well, I'm going to pronounce it in Spanish, it's Defossé. It's an industrial computer from Argentine universities. It's meant to provide an open source alternative to PLCs. And basically they provide this educational version of the board. And it has a very popular ARM microcontroller. It's called Cortex M4. MicroPython is, I thought you had a slide about it. Well, MicroPython is targeted to PyBoard. It's a specific board for trying Python. I think BBC or the UK government are doing something related with MicroPython also. But there are a lot of ports of MicroPython, and you can run it in many microcontrollers. I'm going to try to play the same. It has MicroPython already installed, so if I open a terminal, I should be able to run Python commands on it. Okay, I'm going to run in miniterm.py, and I'm going to use that board, and basically define the speed. Okay, now I don't see the prompt from Python, but if I write some command here like print hello world, maybe I can make the text a little bit big. Wow. Okay. I can see a hello world here. It is running on a very constrained device. It has only 100 Ks of RAM, and we're running Python on Python 3. So it's very interesting. I'm going to try to import a library that is called LED. I'm going to try to play with the lights that it has. Okay, the three lights are on. I'm going to try to do from PyBoard import LED. Thank you, Juan. I'm going to create a LED instance. And that object has a method called off, and LED. Well, it has some quirks when my text is off. I leave that off, and okay, let me refresh this thing. Hello. Well, I don't know if you could see that, but
Hi. So first of all, I would like to know more details about why you changed from SQL Alchemy and Flask to Django.
I'm ashamed to admit it, but it was the Django admin interface. But that time, that part of the system was developed in 2013, and we didn't have good replacement in Flask and SQL Alchemy at that time. But today, I shouldn't make the same decision. We discovered that the Django ORM is not the fastest one, and SQL Alchemy lets you tune things. You have all the knobs there, and with Django you are blind basically, and we are suffering from that. Fortunately, the system is constrained in the way that we have 5 stations, and it's not gonna grow unless the city grows. Well, if you happen to have the same decision, then choose Django.
Thank you. Just another question I'd like to ask. It will be about MicroPython, and have you done any performance tests to check if you could use it in your previous application and replace those standard microcontrollers with this solution?
That's an interesting topic. The speed is good enough to detect things because all the interrupts are capturing C. The problem is that when you have dynamic allocation, you cannot give many warranties about the system. You can test things, but you are not completely sure. I'm not the guy who writes the firmware for the microcontrollers, and if I were, I wouldn't go to sleep peacefully if I knew that something may give a memory error or something. For the time being, it's a nice toy, a nice thing to do, and maybe to teach programming to kids, it's great because you don't have to deal with Arduino IDE or anything like that, but I wouldn't use it in production for now.
On your current solution, your device is sending messages over MQTT protocol, and the MQTT send the messages to store data on Django using RM. Is it correct?
Actually, the system is working with the POL system. It's asking for data, and we're trying to move to this scenario. We are currently working with a greenhouse where we have different controllers that are not in fixed places. Maybe the guy who is in charge takes one away, put it somewhere else, and see if the data is more accurate. But for the power monitoring station, we haven't made any changes from the original protocol that was the one that had the picture. Oh, something happened. We would like to have used it, but we have these constraint related with time and sending the timestamps in the frame and synchronizing within the same protocol. So we couldn't do that with MQTT. We didn't know about MQTT either, but if we had, we needed to solve this time synchronization with maybe something more complex and more costly.